So we are going to do C5, which had a nice drawing for you, and it looked like that. So we had a white puck that had a mass of 1.25 kilograms, and it was going toward a 5.28 kilogram black puck, and the white one was going at 48.3 centimeters per second. Now, I realize it says centimeters per second and not meters per second. Some of you freaked out. Do I have to convert it? No, that was one of the cool things about momentum. Is again, T is just equal to mv, and it really doesn't matter what the velocity's in, as long as they're all the same. So here, if it's in centimeters per second, then your answer is going to be in centimeters per second and stuff. So it doesn't really matter as long as it's consistent. So it can be kilometers per hour, meters per second, miles per hour, whatever you want it to be. It doesn't have to change. So when the white puck comes in, it goes ah, and it hits the heavier black one, and it bounces backwards over here. And here now it goes from going 48 seconds down to 12.8 centimeters per second. So it slows down considerably, and it's going backwards-ish. So we've got that. So now we want to know what happens to the black puck as a result of that. So the black puck, any guesses?
Oh,
Just instinct.
it has the 48 has 2 points, so
Yeah, if the white puck comes along and smacks it, it should go forward. But if this one kicks off to the right slightly, this one would kick off. Yeah, so we're going to estimate maybe something in that direction. So mentally, it doesn't hurt to kind of have a mental picture of what do you think is happening here. So initially, again, we have what is the initial momentum? Well, that was the 1.25 is traveling at 48.3. So this will be centinewton seconds, which will be a weird unit, but we can deal with that. So here we're going to get 60.375. And that's how much we have before the collision. So after the collision, we should still have that. Well, again, we want to figure out how much momentum do we have in this thing after the collision. So we're going to have the 1.25 times the 12.8. So that gives me 16.0. But of course, that's really going 2 directions. It's going both backwards and off to the right. So we said that this is 120 degrees, which means this internal angle here must be 60. So if that's 60, then here, of course, I want to use cosine of 60 times 16.
yes.
And I get 8. And over here, I want to use sine of 60 times 16. And I'm going to get 13.9. So far, this is just like we've normally done it, except normally our triangle was up here, and now all of a sudden our triangle's down here, so that part's a little bit weird. But not that terribly weird, because again, the black one, we say, well, hey, we figure is going to be going both forward and over to the side. Well, clearly his over to the side part has to be equal to his over to the side, so this one still has to be 13.9. Now, what we said was, though, that the total forward still has to be the total forward before, but now this forward one is really going,
Negative.
backwards or negative. Very good. So we had originally said we have 60.375 was going forward before the collision, and then afterwards we know we're going to have the momentum of the black one. So P of the black one plus the momentum of the white one, but normally the momentum of the white one was going forward. This time it's going backwards. So we're really going to add the negative 8 here. Does that make sense? So what we had done before was we would subtract, but now we're going to subtract a negative number, so that's really going to make it 68.375 must be the momentum of B going forward. So that means this side must be 68.375. So instead of subtracting, we had to add it because it bounced the other way.
But I thought, for 13, that you put that it equals the bottom part.
Well, yeah, because the total to the right has to equal the total to the left.
But wasn't it total up equals total down?
Well, that was when we were going sideways. This time we're going,
Oh, okay.
so that's still sideways. So, yeah, now that we have our little triangle, of course, all we got to do is Pythagorize now. So, and we end up with 69.8 is the hypotenuse P going this way. And again, we want to find V, so if this is P equals MV, so to find the V I need to divide by the M, and which M do I need to divide by?
5.20.
Yeah, the black mass, which is the heavier one, so 5.28. And that gives me 13.2. Sorry, not meters per second, that would be centimeters per second. And then to find the angle, again, the angle here, this is opposite and this one's adjacent. So we just want to take tangent to the -1 of the opposite side, which was 13.9, over the adjacent side, which was the 68.375. And that gives us 11 degrees to the left. And the answer says 13.2 at 12 degrees to the left. Do we hyperventilate over uncertainty? Well, we shouldn't. Some of you probably do. But no. So that's it.